Friends, good morning everyone. Today's subject of discussion is Reimer-Tiemann reaction. This is named after the two scientists Reimer and Tiemann. And in this reaction, carbenes are the intermediates formed. As we know, Reimer-Tiemann reaction is one in which I take phenol and treat with chloroform and a base like sodium hydroxide or potassium hydroxide and heat it at 70 degrees centigrade followed by hydrolysis. I'll get corresponding orthohydroxyaldehyde, that is salicylaldehyde. Conversion of phenol to salicylaldehyde by treating with chloroform and aqueous base is called as Reimer-Tiemann reaction. And this salicylaldehyde which is formed, it can oxidize to give salicylic acid. And hence, for the preparation of salicylic acid, salicylaldehyde can be a raw material. And for preparation of salicylaldehyde, we can use phenols. Here, the carbenes are the intermediate form. Let us look into the mechanism how the carbenes are formed as an intermediate. It occurs in the first step. The chloroform reacts with a base like potassium hydroxide or sodium hydroxide. This chloroform carbon hydrogen bond is weak because there are electron withdrawing groups attached to the carbene and they pull the electrons. Once they pull the electrons from the carbon has electron deficient. With less amount of electrons, it is holding the hydrogen with it. Means the carbon hydrogen bond is weak. As it is weak, it is an acidic enough to lose the proton. And as a base like potassium hydroxide, it is basic enough to accept a proton. As we know, the base is a proton acceptor and acid is a proton donor. OH minus abstract proton and it loses as water molecule. As the hydrogen leaves its electrons onto the carbon and moves away as proton, it gives rise to a carbene ion. Carbon with electron richness is carbene ion. The next step, the Cl, it takes out its electrons and along with its electron pair, it combines with sodium or potassium, whatever it may be the case, and it loses as potassium chloride or sodium chloride accordingly. And this gives rise to dichlorocarbene. Once the carbon hydrogen bond has occurred with the gain of electrons to give carbene ion, another time these electrons are taken away from chlorine. Once the electrons are left and the bond breakage has occurred, and once bond breakage has occurred with the loss of electron pair, that's why they have become neutral. Carbenes are neutral carbon species but electron deficient in nature. A carbene is generated. This carbene which is formed reacts with phenol in the next step. Phenol reacts with this carbene. Phenol, the lone pair of electrons, the OH bond breaks, these electrons moves, forms the double bond. It has to maintain its valency, this carbon, that's the pi electrons moves onto the next adjacent carbon. Once that electrons moves, it becomes a carbene ion. This is electron rich carbon and this is a carbon electron deficient in nature. This is electron deficient and this is rich. Naturally, the reaction can occur. These excess electrons, carbon ion electrons, are given to dichlorocarbon and a bond is formed between the CCl2 and the phenyl carbon. Once the electrons are donated to carbon, a carbon ion is generated. Carbon ions, as we know, they are unstable. To become stable, it combines with H plus from the reaction medium and it becomes CHCl2. Now this CHCl2 undergo hydrolysis. H plus OH minus. The carbon here is electron deficient and it is a positive center because it is attached to two electron withdrawing groups that are chloro. This is the positive center. OH minus is electron rich. That's a OH minus attack on the positive carbon. Once it attacks the positive carbon, it has to maintain its tetravalency. That's why carbon halogen bond breaks and this loses as Cl minus. Cl minus combines with H plus and loses as HCl. And here the chloro group has got replaced, substituted by OH. It underwent nucleophilic substitution reaction. Then this is the positive center. The oxygen hydrogen bond breaks. This electrons moves to form a double bond over here. Once it forms the double bond over here, the carbon become 5 bonded, which becomes unstable. That's why it kicks off chlorine. Once it gets kicked off, these electrons are taken away, giving rise to H plus. Electrons are given away, giving rise to Cl minus. H plus and Cl minus, they combine together to lose as HCl and I'll get corresponding aldehyde group attached to it. Then this can come back to enol form and it gives rise to salicylaldehyde. This is Reimer-Tiemann's reaction. Next class we can deal with the other reactions of carbenes, that is rearrangement reaction. Till then, have a nice day. Thank you.